So today we're going to be looking at one of two Maxcom 16Es. We will look at the other one on video, but we won't do it consecutively or you'll be fed up. It's a low serial number. It's 0000145 from March 82, and it's a Maxcom 16E, and that's about the most immaculate one I've seen for quite a bit. So, they sent a mic in. We'll come back to his mic. It's probably absolutely normal and standard, but we'll do it on the, unless of course I haven't got, yeah, here's a Comptron labelled one, so we'll do it with our standard replacement one for now, and then we'll come back to make sure it's set up for his mic. These usually do about 4 watts. It's even come with a power lead, although we do produce a power lead, which is actually better quality than the factory original. Right, we'll get that connected up. What we find with the Maxcom chassis is that it is reliable, but the detector can drift. Greeted with a dirty volume control. Right, let's make sure we have got the test equipment on. We want picture in picture. We're on channel 20. Let's go into transmit. We'll use the 3 watt scale. We'll connect to the test equipment through the aerial socket and the extension speaker socket when I find this plug. These don't have public address. Not that many people want to use that, but it's a useful test feature. Oh, it's 2.8 watts. Switch the other test set behind me on, because we're going to be wanting to do a deviation. It is 2.75 watts on channel 40. And on channel 1 it's 2.85 watts. So if we go back to channel 20, switch it to low power, it is doing 100 and, no it's not, it's doing 280 milliwatts, which is what is going to be 10 dBs of that, so that figures. Back to full power, 953 milliamps, which is quite a lot for that power output. For what it's worth, the deviation on this test set says wallow is 1.5. We won't be doing the VCO. And frequency. Test set's been on for hours. CB27 79109. So it's pretty close. So put that into the signal generator. So we're testing it exactly how the radio is. Basically it needs to be about better than 1 microvolt. This one is 0.53, which is absolutely fine. And for 10 dB, 0.5. For 20 dB, 0.85. Squelch to full on the radio. And I want the set. I'm not showing you the right thing. I want the radio to have the squelch open at 100 microvolts. We're at 1 at the moment. 1, 3, 10, 20, 100. It's opening at 5.6 millivolts. Well, at least it opens, which is more than some sets do. And then at the opposite end, we'll park that at 0.3 of a microvolt, switch it to standby, set the squelch to threshold, switch the signal generator back on. It's coming in at 0.57. Now we're going to put the test set to S9, which is 100 microvolts for a CB radio in the UK. And that doesn't say 9. Let's increase the signal generator. So on this radio, S9 at the moment is 290 microvolts. So it's lazy, doesn't have a meter lamp. Volume control 30. And on transmit, when we key up, it reads 4, which is correct, but the radio's not doing 4, but that's the way they are. So I put my soldering iron on, because we're going to need to unsolder the speaker. So it's a radio which you could describe as working, and I doubt it's been messed with, and it's probably how it came out of the factory 40 odd years ago. So some of these you can adjust the meter sensitivity, there's a preset, and some you can't. I always say don't be tempted to modify sets which don't have the preset, or you're losing history. Right. So the reason we don't do the VCO voltage control oscillator generally to the synthesizer is because you need to actually add some extra parts in. At the factory they use a pin jig to set the VCO. So the bare board, when it's not mounted in a chassis, with whatever parts they put in at that point is tested and is aligned at that point, and it saves them putting about 3 parts in. That cuts costs. Right, let's see whether we can do a tune-up. I'm tempted to do the switch cleaner. That can be soaking in. Right, that's one job done. So we are on the main meter. No, we're not. Put the main meter on the inset picture. We're going to do the transmitter. So I'm on the 3-watt scale, so we're towards the end of the full scale deflection. So that was about right. That wanted a little bit of adjustment. That's peak. We're now starting to drop rather than increase because it's warming up. Now go to the 30-watt scale, so we have gone over the 3 watts. So we're at 3.6. Just need to make sure all these coils are in the right position. These are semi-adjustable. .6 is where we are. When that cools down, it will be a little bit more. Not many new sets actually do above 3.6, so there you are. Don't think you're being diddled with 0.4 too little. Remember, this is an industrial test set, and it's not reading interference, it's only reading what the fundamental power is. So if I put this on something like a Targi power meter, it's probably doing 6.5 watts on one of those meters. So let's go to another channel. Channel 40, 3.55. Channel 1, 3.65. Let's go back to channel 20. The current consumption is now 1.006. So we've gone up only, what, 50 milliamps? and we've gone up nearly a whole watt. Low power now, it's 380 milliwatts, and it may be adjustable. If it is adjustable, it's this preset. There we go, 400 milliwatts, it's adjustable. Let's do the frequency while we're kind of in this area. So it's the red trimmer next to the reference crystal. So it's still got enough leeway for it to be spot on frequency. Next we'll put it on the test set behind and we'll look at the deviation. It was 1.8. Deviation is there. Now we're going to test it with his mic. It's very, very marginally higher. Probably I can make it do 2.6. We'll leave it at that. So is our fairy lights... Oh, I'm not unplugged from the other test set. That's better. And we key at what we're getting now on the fairy lights. Well, we don't want them all to light because it would indicate it's doing more than 4 watts, which it isn't. Remember, that's only into a dummy load. If you put this on an aerial, it might read 1, it might bang across. The radio's still doing the power, which we say is 3.6. So don't think what this meter has anything to do with the real power coming out. So we're set to 4, just toggling the higher one. So on low power it probably reads 1. Let's have a look. Doesn't mean it's doing 1 watt because we know it's doing 0.4. There's a relative power meter, and I keep saying new sets that, all to my knowledge, apart from the Midland 78, don't have a relative power meter. They have a pre-programmed power meter, and a microchip, when you press transmit, swings across regardless of whether the set's developing any RF energy or not. So it's no different to having a TX light, but it's what people want to see. Meter banging across, even though it means nothing. You can even take the output transistors out, and on current models the meter will still swing across. Fake. They're all doing it. So we've done that. Let's have a look at the receive. See if we can get a little bit more out of it. There's nothing wrong with the way it is, but the important thing is to check the detector. So I'm going to put 100 microvolts on the signal generator. Let's look at the oscilloscope. So I'll just bring a bit more volume on. So we get a meaningful trace. And this is the thing that drifts the most on the Maxcom chassis, as used in a lot of sets at this time, including the Midland Precision series. So the idea is for the detector, the FM detector, is that 1 kilohertz tone is shown as that sine wave on the oscilloscope, and we want that to be the maximum amount. Now we just went up a little fraction there, so it wasn't quite at peak. It won't be noticeable, but it might be make a difference on the instrument. So if it's wrong one side, it'll be garbled. If it's wrong the other side, it'll be really quiet. So we'll go back to a much smaller signal. We'll put the SINAD meter up on the oscilloscope, on the inset picture. And what we're looking for is to set this for about 4 dB, so we're not saturating the receiver. So that's about there. And then, as we hopefully improve the receiver, I back off the signal generator so that we have only just enough signal to do these adjustments. So on the detector we need 100 microvolts, because it says so in the service manual, yeah? So we'll start with what they call the front end. Worse. Where it was exactly where its peak is. Try the next one. Wow, that was miles out. That's made a massive difference. Now back off the signal generator. Worse. That's improved as well. Back off the signal generator again. There we go. I'm just going to do these again. Remember, at the factory they don't have time to go backwards and forwards. They'll peak it to a line and it passes on the conveyor belt. There we go. Now I think that's going to be quite a lot better. Touching the case seems to give me an improvement, but we'll try it, see what we get without touching the case. So we're now getting 0.48. Especially if I knew where my pen was. There we are. 0.48 microvolts for 10 dB. We're getting 0.47, and for 20 dB, getting 0.73. Let's go back to the 12 dB. And I'm going to touch the case. So we've earthed the radio. It's now 0.41. Let go. Some sets do that. And this aerial is grounded. So that's an important fact. It tells you to where it went on the instructions for that type of aerial, which is the Antron 99. But of course we're on the test equipment at the moment. Right, so that is peak. Absolute peak. We have an improvement, and now we need to do the squelch. So I'm going to turn the squelch to full. Once again, let's see where we need to be to open that squelch. No difference. So we need to adjust the squelch preset, which is here, until such time as it comes in at 100 microvolts, which is there. There we are. So now back it off on the attenuator, and there it's coming in at 100 microvolts as I've set it. So now we'll do the sensitivity one. So we'll turn the squelch on the radio with the signal generator on standby. Switch the signal generator back on. It just about came in at 0.3 then. It's actually 0.4. So that's improved the sensitivity. And there won't be an meter adjustment on this model. So what the meter says is what the meter says. Let's see what the meter does now say. So there we are, we've got the S9 just coming on, and we're on the 300 scale. It's now 190 microvolts for S9. So it has improved from 290 microvolts to 190 microvolts. So it's less lazy than in fact it was. So mic supplied is working. That's super duper. Now I sent 2 of these in. So I said we're going to do another of those box sets. We've got Rotel RVC220 next. Then we'll come back and do the other Maxcom. I don't want to do identical sets consecutive. You'd all be bored. Right, let's solder this back on. So that is a straightforward retuning test and a bit of switch cleaner on the volume control. Really nice condition. Got one on my shelf up here which couldn't be the opposite. I've got one which is in dreadful condition. Also doesn't work. And it big time doesn't work. So we are in Buxton tomorrow. We'll be seeing Michael Dranfield, who has a YouTube channel fixing mainly television sets. We've got a large Samsung plasma item that we don't want, so we're going to give that to him. I don't think there'll be any video of him, that would be not fair. But that's where we are tomorrow. We'll take some footage. And out in Buxton, there's about to be snow. I've been to Buxton in June and got snowed in the church car park. Big 4-manual hill organ there, which I used to work on when I was at Groves Organ Builders. We're not there to look at that. We're just going to go and see Mr. Dranfield just to say hello. Right, we'll just put this on the aerial. One niner Roger. Notice it's on 5 when I key up. Doesn't mean it's doing 5 watts because we know the radio's doing 3.6. That's what I'm on about. it's just gone 5 o'clock. They're all having their tea. TX light's not working, so we're just going to have to go back into this set and do the LED, which is quite time consuming. So we can't quite finish the video. Okay, so it's much easier to get to than the 4E. Being able to take 2 screws out of the front and swing it forwards, and then take the 2 screws out which secure the board. Take 2 wires off. The black one is to the edge, and then the orange one is to the other side. So we've taken the LED out. It's got a bit of sleeving which we'll put on the replacement LED. So it's just a matter of getting this the right way round. So you can kind of see inside through the opaqueness which element is which side. So these are 3mm type, and we'll cut the leads to the correct length now. You see you've got the TL489 CP Texas Instruments bar graph driver chip there. Right, I'll get that soldered back. Right, so we've got the wires back on. So with it in this state, I've powered it back up. We're going to just check it works. Press transmit, and it works. Good. Of course, when I'm doing this, I've got it on the aerial still because I was off the test instruments and I've got it on low power. So I'll get it, put it back together. Okay, so we're finally done. Oh, I need to put the knobs back on. Have these got pointers? No. Did dust the front escutcheon whilst I'd got it off. Right, what does that leave us to do? Well, we'll flick around the channels again. 1 nano, roger. Oh, we're on low power. 1 nano, roger. Very good. Right. Well, we're doing an on-the-air test with that, and I'm going to. I'll tell you what we'll just do. I'll put it on channel 20. Just see if we can hear anything on the walkie-talkie about the speech. Obviously, we're going to get feedback. Testing 1 2. Testing 1 2. I'll just pop it on low power. Testing 1 2. Testing 1 2. That's our mic. And then we'll just try it with his. Testing 1 2, testing 1 2, testing 1 2, 1 2 1 2. There's a bit of a hum on that I can detect. Let's just check that it's actually got a screened lead on it, and it's not one of these dodgy mics which doesn't have a screen lead. No screened lead. Oh, there is, I tell a lie. It's there. I take my words back. I just felt a bit hummy. What we'll do, I'm going to start the test when we do the on the air test with our mic, and then when we get to the 5 mile point, I'll swap mics. We'll do the rest of the test, and then at the end we'll compare the 2 mics to the base station as well.
Testing 1 2, testing 1 2 1 2, testing 1 2. Testing 1 2, testing 1 2, testing 1 2.
This time round they sound the same. Anyway, that's what we're going to do. So thanks for watching Maxcom Apollo 16E from 1982. Don't see that many of these, but strangely enough we've done about 4 recently.